Okay, this is a review on factoring. Um, First of all, the word factor. In mathematics, factors are simply numbers that are multiplied together. So any two numbers or multiple numbers that you want to multiply together are factors. For example, if you look over here, 6 is the product, meaning two factors multiplied together, of 2 and 3. 2 times 3 is 6, so 2 and 3 are your factors, and 6 is the product. Specifically, 6 was broken down into prime factors, which means two numbers that are prime numbers multiplied together to give you 6. Anytime you prime factor a number, all of the factors will be prime numbers. All right. In algebra, um, we factor by rewriting a polynomial as a product of a lower degree polynomial. May not mean a whole heck of a lot to you said like that. But the idea is if you start off with a quadratic, like this one, you're going to factor that into a product or two factors of two linear functions multiplied together. And you could certainly multiply x plus 1 and x minus 2 out, and you'll see that you get x squared minus x minus 2. Whatever method you were taught, whether you were taught FOIL or box or distribution or anything of that sort. I will be referring to FOIL for the most part, so hopefully most of you know the acronym FOIL: first, outer, inner, last, and we'll go through that a little bit. So we're going to look at 5 different types of factoring, and it says thanks to Mrs. Donahue. I don't know who that is, but she is the one who created this worksheet for us, so thanks to her. All right, the first type of factoring out a GCF, which is the greatest common factor, and those are going to be monomials. A monomial, mono, meaning one term. So these things are going to be something where it is one term, which means you're not going to factor out things which are added and subtracted together. It's going to be one thing of combination of variables and constants multiplied together. Find a common monomial in the polynomial or the GCF and factor it out. Basically what we're doing is the idea of reverse distribution. So if you take something and you multiply it into a parentheses, we're taking that process backwards. That's the first thing you always do in any type of factoring problem, is look to see whether you have a greatest common factor to factor out. All right. The biggest thing is you can sometimes find a common factor, but you might not find the greatest common factor. In order to factor something completely, you need to find the greatest common factor, meaning what is the biggest number, or monomial in this case, that will go into both of the terms or all of the terms that you're factoring it from. Let's take a look at some examples and see if we can figure this out. Letter A, 6x squared plus 12x. What you should notice is two things. One, the variable is the same in every term. We have two terms. This is a binomial. Two terms. Terms are separated through addition or subtraction, not multiplication and division. So 6x squared is a term. 12x is a term. The combination of adding those two creates two terms, which is a binomial. Within the binomial, each term has a common variable of an x. Each term also has a coefficient, or the number part, of a 6 and a 12, of which there is a number, and actually multiple numbers, that go into both 6 and 12 evenly. We are looking for the biggest. So the biggest number that goes into both 6 and 12 is 6. Okay, 6 goes into 6 once, 6 goes into 12 twice. It's the biggest number that goes into both of them. Some people might think, well, it's 12. No, that's different. 12 goes into 12 evenly. It does not go into 6 evenly. So then you're looking for the greatest common factor of the variable parts, because that's part of the expression. Well, ask yourself, We know that x goes into 12x, x goes into 6x squared, because x goes into itself once, x goes into x squared by multiplying it by x. So x is definitely part of it. Why could I not use x squared? Well, the answer to that is x squared does not go into x evenly. That's better. So the concept is, what you're looking for with the variables is the greatest common factor of a variable will always be the, the common variable with the smallest exponent. The 6x squared has a squared. The 12x has an x to the first power. We just don't usually write the 1 there. So x to the first is the greatest common factor because a bigger number of variables cannot go into a smaller number of variables. So 6x is the greatest common factor. So in factored form, the 6x is what we would have distributed into a parentheses. Now the question is, what would we have left in this parentheses? Well, we're factoring a greatest common factor out of a binomial, which means we're going to have a binomial left over. So ask yourself this question: what would I multiply by 6x to get 6x squared? And the answer to that would be x. Now, if you distributed the 6x times the x, you would get the 6x squared. Plus, what would I multiply 6x to get 12x? 6x times 2 would get me 12x, so a 2 would go there. And then you could always double check this by distributing it. 6x times x would give you 6x squared. 6x times 2 would give you the 12x. We are reversing the distribution process. So if we look at letter B, 12x plus 42y. First thing I notice is the variables are different. I am not going to factor a variable because I don't have the same variable in both terms. I have a binomial there, 2 terms. I do know that something goes evenly into both 12 and 42. Now, obviously, what you might think is that 1 goes into everything evenly. 1 doesn't do you any good to factor it. But 2 would go into 12 and 42, but it's not the biggest one. 4 would go evenly into 12 and 42, but again, it's not the biggest one. I believe the biggest factor here is going to be a 6. Because 6 goes into 12, 6 goes into 42. I don't think there's a bigger one. One surefire way to know is once you factor it, if you look at what's left over inside your parentheses, if you still see a greatest common factor, you didn't take the biggest one out, just take the greatest common factor out and then multiply it on the outside. So the greatest common factor of 12x plus 42 is 6. So 6 would go on the outside of the parentheses. I'll still have a binomial left over. 6 times what gives me 12x? 6 times 2x gives me 12x. Plus 6 times what gives you 42y? 6 times 7y would give me 42y. And that is factored because 2 and 7 do not have anything in common other than 1. And x and y don't have anything in common. Okay, same idea for C, the greatest common factor. First, deal with the numerical portion, the coefficient. I know 4 and 24 have a greatest common factor because 4 goes into 4. It also goes into 24. So 4 is the GCF of the numerical coefficients. They both have x's. One is x to the 4th, one is x cubed. The smallest number of those exponents is the one we're going to factor out. So I'm going to factor an x cubed as my common factor. So in factored form, the 4x cubed is on the outside because we're reversing the distribution process. Still have a binomial left over. If I take 4x cubed and I have to multiply it something to get 4x to the 4th, I would have to multiply it simply by x. And then 4x cubed times what would give me 24x cubed? Well, 4 times 6 is 24. X cubed times 1, we don't have to write the times 1 in there. So it's 6 times 1, but that's just 6. So x plus 6 is in our parentheses. And again, if you distributed it back out, you would get the original expression that we started with. So the first thing you do is always look for a greatest common factor. And obviously there can be more than binomials. There could be 3 terms, 4 terms, 7 terms. It just, however many terms there are, if you have something in common, do the greatest common factor first. If not, we move on to the other stuff. So type 2, factoring. Sums and differences of perfect squares and cubes. We're actually going to skip the cubes part. We're going to worry about that later. So for right now, we're just going to cross that off. And let's see, letter D is an example of a perfect cube. We're going to skip those. Differences of squares. So that means literally what it says. You have a perfect square, another perfect square, and a minus sign in between. If you have that, it will always factor in this general form. The a squared minus b squared is going to be a plus b, a minus b. Always. The thing you're going to have to recognize is, do you actually have perfect squares, and do you have a difference in between? The sum of perfect squares, if that was a plus in between the a squared minus b squared, if there was a plus there instead, does not factor. Okay, we're going to talk about that probably during class. So the first one, a, y squared minus 16. Y squared is a perfect square. 16 is a perfect square. The minus sign in the middle means that we now have a difference of perfect squares. If that's the case, it will always be the square root of the first one, the square root of the last one, and then 1 plus, 1 minus. Always. Y plus 4, y minus 4. Order doesn't matter. You could have written y minus 4, then y plus 4. That doesn't make any difference. Letter B, 4x squared minus 25. 4x squared is a perfect square. The square root of that would be 2x, right? 2x times 2x would give you 4x squared. 25 is a perfect square, and there's a minus in between. So what we get is 2x plus 5, 2x minus 5. Really, the difference of squares is one of the easiest things to do. Okay, letter C. I'm going to kind of slide C over here. X to the fourth. Now that is a perfect square, but it doesn't say square, but it is a perfect square because there's something I can multiply times itself to give me x to the fourth. And that would actually be x squared. 16, that one you should know, we've already done it, is a perfect square. Oops, forgot my squared. So x squared minus 4, x squared plus 4. You have to be careful on this one. This one actually factors further. The x squared minus 4, right there, is another difference of perfect squares. X squared itself is a perfect square, 4 is a perfect square, and there's a minus in between. That one actually breaks down to x minus 2, x plus 2. The x squared plus 4 is not a difference of perfect squares. It is a sum of squares, and a sum of squares does not factor further. So that one has to stay like it is. All right. Letter D. Letter D, again, I said we were going to skip. That's the difference of cubes. We will talk about that maybe at some point, but not now. Letter E. Letter E is a difference of squares. Now, let me tell you how to look at these things with the variables. If a variable has an even exponent, it's always going to be a perfect square because half of that exponent will be the square root. For example, I've got 9x to the 6th minus y to the 8th. The 9 we should know is a perfect square. That's an easy part. So we're going to have a 3 and a 3. Attached to the 9 is the x to the 6th. Half of its exponent, because 6 is even, is 3, so it'll be x cubed. X cubed. And then with the y to the 8th, half of the exponent, because it's even, will be its square root. So we've got y to the 4th. So we got 3x cubed plus y to the 4th, 3x cubed minus y to the 4th. So double check to make sure that you can't factor any further. The first one is plus. We know we can't do that. The second one has a minus, but while y to the 4th is a perfect cube, 3x cubed is not. So we are done with that one. Sometimes you might have to do these in multiple steps. Maybe we'll have a GCF first, and then it might create a difference of cubes. So let's take a look at those. In the first one, 3x squared minus 27. You should notice that 3 goes into both terms. So if I factor the 3 out, I'll still have a binomial left over. 3 times what will give us 3x squared? Well, that would be x squared. Remember, we're reversing the distribution process when we factor out a greatest common factor. And then 3 times what would give you the 27? And that would be 9. Then you need to recognize, oh, wait a minute, x squared minus 9. 2 squares, and there's a difference in between. So that will factor to x plus 3, x minus 3, being very careful not to lose the first 3 that we factored out in the first place. Okay, same concept with 4x squared minus 16. Both of those are perfect squares as it is, and you could go ahead and factor them as a difference of squares, but it's still better to factor the common factor out first. In this case, the common thing that goes into both is 4, which will leave you with an x squared minus 4 on the inside of the parentheses. And then x squared minus 4, again, is a difference of squares, so it factors further. So we'll get x minus 2, x plus 2. Okay? And then the last one, 8x squared minus 50. Well, let's see. 8 is even, 50 is even, so I know I can factor out a 2. Does 4 go into both? 4 goes into 8, but it does not go evenly into 50. 8 itself does not go evenly into 50, so it looks like my greatest common factor is 2. 2 times, it looks like 4x squared, and then 2 times, looks like 25. And again, 4x squared and 25 are perfect squares. There's a difference. We must factor them. 2. Square root of 4x squared is 2x. Square root of 25 is 5. One's plus, the other's minus. Difference of squares. Okay, moving on. Type 3 of factoring. When we have trinomials where the leading coefficient is 1, in other words, we have x squared plus bx plus c. There's nothing out in front of the x squared, which is assumed to be 1. There is some kind of a number in front of the x, and then we have a constant term. These two are special forms. Okay, these are actually what are called perfect square trinomials. If you recognize them, it makes it quicker and easier to factor these. If you don't recognize them, it's okay. You can still factor them in a different way, and we'll see that when we get down to the second set of examples here. First set of examples, however, is saying if I recognize this as a perfect square trinomial, it means that there's no coefficient out in front of the x squared. The last term is a 9. That's a perfect square. If you take the middle term, take half of it, which is 3, and square it, you'll get 9. That makes this a perfect square trinomial. If that's the case, it's going to factor to be x plus 3 squared. It will always be the square root of the coefficient here, the square root of this, and the same sign as what's right there. I did not get those circled very well, and I apologize for that. So let's try that again. X plus 3 squared. And again, what we're looking for is the coefficient here, the constant here, and whatever this sign is right there. So looking at letter B, again, the last term is a perfect square. If I divide this one in half, it's -5, and then I square it, it's 25, and I do get this part right here. So this is a perfect square trinomial, which means it's going to be x, it's going to be 5, and the same sign as the -10 part, and then squared. Again, if you don't understand this part, and this is a little bit too much for you, you can still do it in the next way. The last one, I'm just going to write up there, if you've already figured out how to do it, would be x plus 2 squared. It does work as a perfect square. The ones below this are not perfect square trinomials, so this is the method you're probably going to want to try and use to do these problems for the most part. To do these, you do need to be good at your multiplication and addition, that's for sure. So the idea is, what do I need, and this only works, by the way, when the coefficient here is 1, it's what do I need to multiply to 6 but add to +5. Those are what's going to create my factors. What numbers multiply to be 6 but add to 5? In this case, there's only two multiples of 6, 2 and 3, 1 and 6. 1 and 6 cannot add to 5, but 2 and 3 can. So my factors are x plus 2 and x plus 3. And what you would find is if you FOIL those out, you'll end up with x squared plus 5x plus 6. In letter B, same concept. What numbers can I multiply together to get 8, but when I add them together, it'll give me -6. Well, in this case, 8 has a lot of factors, 1 and 8, 2 and 4, and you got to consider possibly all the negatives. And the reason we have to consider that is because if I take 1 and 8, it's going to give me 9. If I take 2 and 4, it's going to give me 6, but none of those gave me negative numbers. But remember, what numbers can multiply to give you positives? Well, either 2 positives or 2 negatives. So in this case, I can multiply -4 and -2 and still get +8. And when I add -4 and -2, it's going to give me -6. So my factors are x minus 2, x minus 4. Okay, let's try it with the next one, with letter C. X squared minus x minus 2. What can I multiply together to give me -2, but when I add will give me -1? Well, to multiply two numbers together and get a negative, to get that -2, they have to be two numbers of opposite signs. Fortunately for us, 2 only has two factors, 1 and 2. Those are the only two numbers that multiply together to give you 2. The combination, however, x has to be 1 positive, 1 negative. Well, I know the factors are going to be 1 and 2. But now you need to ask yourself, which one of those factors, the 1 or the 2, is actually going to get the negative sign? Well, if I want to add two numbers together, which is 2 and 1, one of them has to be negative to get to that -1. The only way to do it is if negative is with the 2 and the 1 is the positive. Because now the -2 and the +1 will give us the -1 from the middle. Okay, just because we're changing the exponents on D doesn't really matter. It still factors the same way. We're actually really not going to deal with that too much right now, but I will write the answer up there for you guys. The only way we can factor x to the 10th is if we have an x to the 5th in the first spots there. And then the factors of -10 that are going to add to -3, well, 10's multiples are 1 and 10 and 2 and 5. 1 and 10 won't come anywhere near 3, but 2 and 5 can work. And in order for us to get a -3, the 5 has to be the negative number, and the 2 has to be the positive. Now, when you add -5 and +2, you get the -3. All right, all of that works just fine, and it will also work for the ones here above, you could have done it exactly the same way, until we introduce a number out in front of the x squared term. And this is the last ones that we're going to talk about. I've seen a whole bunch of different methods here. Some of them I like, some of them I don't. And if I don't explain it in a way that you like it, I can try to help figure out a different way for you guys to do this. Because the number out in front of the x squared, we can no longer use the thinking that we just did in type 4. So the idea is still first look for a greatest common factor. If we have one, pull that out first. If not, we can't factor out a greatest common factor, then we have to go straight to seeing, can I reverse the FOIL process somehow? Because that's really what we're doing. Well, letter A, 6x squared minus 11x minus 10 does not have a greatest common factor. Okay, there's nothing in common there. But I am going to be able to reverse the FOIL process. And again, I've seen all kinds of different methods to do this. My method has always just kind of been, it's almost a guess and check, but it's a logical guess and check. So you have to ask yourself, to get this first number, 6x squared, there's only a couple of possible ways to do it. Either 1x times 6x or 2x times 3x. One way or another, we know we're going to have an x in here. We just got to figure out what the coefficients are going to be. I'm going to start with 2 and 3 because I think that might be the right way to go. If it's not, we might have to come back and do a 6 and a 1. It's got to be a 2x and a 3x or a 1x and a 6x. There's no other choices. In order to get the 10, there's either 1 and 10 or 2 and 5. We're going to have to figure out which combination might work. If I were to try 1 and 10, and the order will be specific here. If I try 1 and 10, if you kind of look at the FOIL process, if I do the outside, that's going to give me 20x. If I do the inside, that's going to give me 3x. That combination of 20 and 3 is not going to get anywhere near 11. 20 and 3 cannot add or subtract to 11. So we're going to get rid of the 1 and the 10 because that didn't work. Let me get a smaller eraser. Let's get rid of the 1 and 10. We need it to add to negative 11. So let's try the other way. Maybe the other way will work better. Instead of 1 and 10, maybe I go 10 and 1. Now if I do the outside, I get 2. If I do the inside, I get 30. Well, I can't add or subtract 30 and 2 to get anywhere near 11, so that one doesn't work. So 1 and 10 definitely was not a good possibility. How about 2 and 5? Let's try 2 and 5. If I put a 2 here and a 5 there. Now if I do my outsides, I get 10. If I do the inside, I get 6. 10 and 6 does not add or subtract to 11. So we're really running out of possibilities fast here. And I'm kind of hoping that it's not 6 and 1. It's kind of tedious if it is. So we just tried 2 and 5. Let's try 5 and 2. Yes, and it looks like this one's going to work, because now if I do my outsides, I get 4x. If I do my insides, I get 15x. 15 and 4 can add or subtract to 11. 15 plus 4 is 19. That doesn't help, but 15 minus 4 is 11. That does help. Remember that this 10 is negative, which means that one of the 5 or the 2 is going to have to get a negative sign. But what we really want to work on is the product of the outside and the inside needs to be, specifically the bigger one needs to be negative, because we want to add it to a negative number. So if we think about this, the 2 and the 2, the 2x times 2 is going to give us 4. The 5 times the 3x is going to give us 15. 15 needs to be the bigger number because we want that to be a negative 15 added to a positive 4 to give us negative 11. So negative goes with the 5 because that'll be the negative 15, and the plus goes with that 2 because that will make a positive 4. All right, erase those lines for the last time. and 2x minus 5, 3x plus 2. If you were to go ahead and FOIL that back out, you're going to end up with the 6x squared minus 11x minus 10. Okay, let's try another one. Let's try letter B. B actually works out a little bit nicer because of the fact that if you look at the first term and the last term, 3 is a prime number, which means it's just 1 and 3 that are multiples. 5 is a prime number. It's just 1 and 5. There aren't many possibilities here. So the first one has to be to get 3x squared, 3x, and x. That's the only possibility. In order to get 5, you've only got 1 and 5. The order will matter. So if I put a 1 here and a 5 here, I think I've guessed right on the first one, because if we switched them, this wouldn't work. Now if I look at my outsides, I get 15. Insides gives me 1. 15x and 1x can subtract to 14x. Now remember, this is negative, so they have to be opposite signs, so we'll make 1 plus 1 minus. This is positive, which means that the bigger combination of the bigger multiples needs to be positive. So the positive needs to go with the 15, the negative needs to go with the 1. So in order to make the 15 positive, it's got to be a 3x times a plus 5. In order to make the 1 negative, it has to be a minus 1. So we get 3x minus 1, x plus 5. All right, last one. 4x squared plus 26x minus 14. Those are some big numbers to deal with, but hopefully you can see there's a common factor. The common factor looks like it's 2, because 4 does not go into 14 or 26. So I think 2 is the common factor. There's no variables in common in all three terms. Has to be in all of them. So 2, dividing a 2 out or factoring a 2 out is going to leave a 2x squared. Factoring a 2 out of the 26x is going to leave plus 13x. And then again, 2 times what would give me the negative 14? That would be a minus 7. And that actually helps if we're going to try and factor this thing further. It may or may not. We'll have to see. If it does, it's going to look like this. Again, 2 is a prime number, and so is 7. So this makes the combinations a little easier. This has to be a 2x and an x. Again, I'm going from the FOIL process. We're reversing the FOIL. In order to get 7, it's got to be a 7 and a 1, so the placement will matter. And I'm pretty sure that a 14 and a 1, if I do my outside and inside, is going to be what we need. So if you look at your outsides, 2x times 7 is 14. If you look at the insides, the 1 times x is 1. I can subtract 14 and 1 and get to 13. The 13 is positive, which means that the 14 part in my multiplication needs to be positive, and the 1 needs to be my negative. So 2 times 2x minus 1 times x plus 7 is the factored form. Okay, hopefully that's a good review for you guys. Hopefully this is not something that you've never seen before. You should have enough information now to do the homework, which is on the next page. Good luck with that, and we will answer any questions that you guys have in class.